Hello friends, today we will try to understand what Workflow Identity Federation is and how it works. So let's get right to it. Okay, so what is Workflow Identity Federation? So in short, in one line, if I have to explain it, it's like if you have something on GCP that you want to access from outside GCP, like maybe say from AWS or Azure or from your on-premise or from a Kubernetes cluster or the pod that is running in the Kubernetes cluster in GCP, right? So workloads that are outside GCP or a Kubernetes cluster or a pod that is running in your GCP at the pod level, right? So you can set the permissions at the pod level. But in short, you can think of it as if something is running outside GCP and you want to access GCP resources from that particular project or that particular workload, then you use Workflow Identity Federation. So before Workflow Identity Federation, what you had to do was you have to create this key for the service accounts, and you have to use that key, and you have to take that key and you put it on you have to export that key somewhere where the workload is running, and you use that key to talk to your GCP resources. But there was not the perfect way of doing it, because if that key gets leaked, then you are in trouble. So in order to mitigate that risk, I think that is the reason why we have this Workflow Identity Federation. And what it does is, again, it allows you to access GCP resources from the workloads that are running outside the GCP. So what it is made of? So Workflow Identity Pools is one of the component of Workflow Identity Federation. Think of it as a way to organize and manage your external identities. So if you are in AWS, then your identity, your IAM roles, your IAM users, those things you can kind of manage and organize them in the Workload Identity Pool. And a project can have multiple workload identity pools, and each pool can have access to different types of resources. So you can have a workflow identity pool that can access your GCS bucket, another workflow identity pool that can connect to or access your Firebase NoSQL database, so on and so forth. So there is another advantage of having workflow identity pools. And what Google recommends is, it says that you should create a new pool or new workflow identity pool for each non-Google Cloud environment that needs access to the Google Cloud resources. So development, staging, production environments. If you are coming from AWS background, then you have multiple accounts for each. You have a account per environment. So you create one workflow identity pool per account, dev, staging, production. So you can control the access tightly. And example providers for Workflow Identity Federation are AWS, Azure, on-premise Active Directory, Okta, Kubernetes clusters running in GCP or outside GCP. So you can see that you can connect your workloads running in AWS to a GCS resource. So what are you gonna do here? So we will look at a demo. In the demo, what we will do is we will create a Lambda function in AWS, and we will access GCS bucket, and we will list the files of that particular GCS bucket in the Lambda function. And we will do that with the way of by using Workflow Identity Federation. So we will not export the service account keys, but what we will do is we will manage this Workflow Identity Federation, and we will access GCS bucket from Lambda function. So the way it works is you have a Lambda function that is gonna have an IAM role. So if you're coming from AWS background, you will understand this better. So you have a Lambda function, it has an IAM account, it has an IAM role, and what happens is when we try to make a call to GCP resource using the SDK, GCP SDK, what will happen behind the scene is the SDK first will talk to the security service token in GCP, and it will get the temporary credentials, and then by using the temporary credentials it will assume the service account, and that service account will allow our Lambda function to talk to cloud storage. We are not going to make our cloud storage public. I will show you the whole thing, and you will see that we will keep our cloud storage bucket private, but still we will be able to access that bucket and list the files of that particular bucket from the Lambda function. So let's get to it and see how the whole thing works. Okay, so we are in GCP Console right now. So the first thing we want to do is we want to create a new project. That's how I like to do stuff from the scratch, and we are gonna name these Workflow Identity Federation Demo X, and everything else looks good. Okay. Okay, so the project is created. Now we will select the project, and the first thing we will do is we will create a GCS bucket in the storage. This is the bucket where we will upload some files manually, and we will try to read them from Lambda function in AWS. Pretty cool. And let's enable the billing here, and we will say create bucket, and we will name this bucket as this is our bucket name, Cloud Identity Federation Demo GCS bucket X. Continue. We just will say region, continue, standard, continue, uniform, continue. Everything is good. Click on create. Okay, now there is nothing here, so let's go ahead and upload some files here that we will list from the Lambda function. Okay, so let's click on upload files. File 1, file 2, file 3. These are good. So there is nothing in these files. They are 0 bytes, but they are good for us because we are not trying to do anything else here. We will just list these files. So we just say open, and 3 files uploaded successfully. Awesome. So now we are done with the GCP console. What we will do now is we will go through the code that is going to read these files, and we will see how that particular thing works. So let's go to PyCharm and let's look at our Lambda function. So this is our Lambda function. It's a pretty simple Python Lambda function. The only thing that we have installed in this one is GCP client library for the cloud storage. That is all we have installed. It's just pip install Google Cloud Storage, and that is it. And then we have created this requirements.txt file, and this is our Lambda function code. So we have this bucket name hard coded in here, which says Cloud Identity Provider, but it should say Federation Demo GCS bucket -x, demo GCS bucket -x, and it says read the files from this particular bucket, create the storage client, get the bucket, GCS bucket, and list the content. That is all it does. It doesn't do anything else. So what I have done here is I have this shell script this shell script is not really doing anything. All it is doing is it is just creating a package for me, so I can upload it to the Lambda function and run it. So all it does is it installs the requirements from the requirements.txt file into a folder called package. You will see that being created here. It goes into that package and then it creates the zip file, and then it attaches or it adds this app.py function, app.py file to that zip file. That is all it does. It's pretty simple. There is nothing going on in here. So basically, how you do it, it's up to you. This is not something that if you do it this way, then only it is going to work. It's absolutely not. It's however you do it, you do it. At the end of the day, you want your code to be in the Lambda function with whatever your requirement file says, this Google Cloud Storage SDK installed in there, so it can run. So let's run this create deployment package.sh, and what it will do is it will install all the stuff that it needs in the package folder, and it added the app.py, and if I come here I will see the package folder, I'll see everything, and it has created this zip file called GCS deployment package. If I extract this zip file, inside there you will see this package folder and you will see this app.py. There is nothing going on in here. So now what we will do is we will create a Lambda function in AWS and we will try to run it. So let's see what happens when we run this, right? So I'm not gonna just get ahead of myself, right? So let's run it, see what happens, and it's gonna fail, but let's see what happens. Okay, let's go to AWS console and see what happens. So I am here in my AWS console, and what I will do is I have to create a Lambda function. So before I create the Lambda function, I'm creating IAM role because I'm gonna attach this particular IAM role to the Lambda function. So I'm gonna come here in the roles and I'm gonna say create a role, AWS services, Lambda function, permissions. I'm gonna say no permissions, don't attach anything. And the tag, if you want to add the tag, you can add the tag. And I'm gonna name this function as read from GCS. Cool, right? Role minus read from GCS, and I will say create role, and my role read from GCS is created. Now I will come here and I'll say Lambda and ignore what you see right now. We will just click on create function, and we will say author from scratch, and I'm gonna say name this function as minus read from GCS bucket. My runtime will be Python 3.8, and execution role, I'm gonna say use the existing role, and the role I want it to use is read from role minus read from GCS. That's the role we just created a couple of minutes back, and everything else I will let it go, and I'll click on create function. Now there is nothing in here, so what we will do is we will click on upload from zip file, and we will upload our zip file to this Lambda function. So click on upload from zip file, upload, and this should be where my code is. Read from GCS, and that's the one we just created 11:43, 3 minutes back, and we'll click on open and we'll click on save. We haven't changed anything. So if you see what is happening here, our handler is wrong, so we will click on edit, and our file name is app.main. Main is the function name, right? So our file name is app, our function name is main. That's what we did here. And click on save. Okay, and everything else looks good, so we click on test and we will say test. Let's see what happens. It failed, right? And it says task timed out after 3 seconds. That's the default timeout we have for the Lambda function. It is obviously gonna fail because it has no idea how to read that particular GCS bucket, because there is nothing going on here, right? So we are not going to change anything in the code right now. What we will do is we will make this function read the files from the GCS bucket without creating the keys for the service account, and attaching with this Lambda function and all those things. So let's see what that process looks like. That's the heart of this demo. So let's go and let's do that. Okay, so let's go to our GCP console, and this is where we will make all the changes. So if you look at the code here, there is an instruction file here which has all the step-by-step instructions that you can just follow, and you can do it at your own pace. But let's go through them one by one and see what we need to do. So the first thing we need to do is we need to enable APIs. So there are a set of APIs that we need to enable. The first one is Identity and Access Management API. So we come here in the GCP console and we say APIs, and go to APIs and Services. Click on Enable APIs and Services and search for it, and click on Identity and Access Management IAM API and click on Enable. So you see the button right now, it is showing manage for me because I have already enabled it. So what you want to do is you want to click on Enable, because you need to enable this API. Don't skip that. Please enable that API so that we can do it the right way. So that's the first API. The second API is Cloud Resource Manager API. So you come here and you do the same thing, and you click on Cloud Resource Manager API and you click on Enable here. Third one is IAM Account Credentials API. So you click on IAM Service Account Credentials API and you click on Enable if it is already not. And the last one is Security Token Service API. And you click on Enable. So that is step 1. Step 2 is adding yourself in the Workload Identity Pool admin role. So you copy this and click on here and go to IAM, and you can see I'm already there. I already have that particular role, but if not, click on Edit Member and click on Add Another Role, select a role and just paste it, select it, make sure you save it and save it, and it should show that you are now part of the IAM Workload Identity Pool admin. So that is step 2. Step 3 is to add yourself in the organization policy administrator. This you can only do it at the organization level. if you are already a part of that organization policy administrator role, then it is perfectly okay. So what you do now is you go to organization policies, and the two policies that we are interested in are Workload Identity Pool AWS accounts and Workload Identity Pool providers. So let's see how we want to update them. So the first one in the instruction, we have to update identity providers for workloads in IAM. So there is this one. Okay, and you click on edit. If you see this button disabled, that means you are missing some permissions. But as long as you can click on edit, you can click on it and you click on customize. Remember to click on customize. Merge with parent is fine, or you can click on replace. I'll say keep merge with parent. Custom policy type allow, and the new value you want to put sts.amazon.com, this guy. And click on save. So there is one organization policy. The second organization policy we want to update is Workload Identity Pool AWS accounts. This is optional, but you should, because you want to make sure that you add your account number, your AWS account number in here, and that is how you can tightly secure it, restrict it only for your AWS account. So just like the previous one, click on customize, merge with parent, custom policy type allow, and in here you add your account number. So whatever your AWS account number or account ID is. So let's see what my account ID is. So this is my account ID. I'll click on copy and paste it, and I will click on save. Okay, so we are done with step 3. Next steps that we want to do, we cannot do them from the console, at least not right now. So for that, what we have to do is we have to start or activate Cloud Shell. So that's what we will do. We will activate the Cloud Shell. Okay, our terminal is on. So what we will do is we will execute some CLI commands here. So the first command we want to run is we want to create workload identity pool. So in here we say gcloud IAM workload identity pools create ID. So you give whatever ID you want, anything you want, you give it here. I'm gonna remove the one, so I'm gonna say ID minus AWS, my ID minus my AWS pool. Description is my AWS pool, and display name is also my AWS pool. I will copy this and I will come here and I paste it, and I will run it. Authorize. If this command is successful, you will see a message which says created workload identity pool ID my AWS pool, whatever name you gave. So that means our identity pool is created. Next thing we want to do is we want to create identity. We want to add AWS as an identity provider. So more or less similar command. We say gcloud IAM workload identity pools providers create AWS, and so this is the whole command. I mean, this is the first part of the command, and here we say ID my AWS provider. You can give whatever ID you want, and workload identity pool is my AWS pool. This is the ID of workload identity pool that we just created in here. So ID minus my AWS pool, and here is the account ID. So whatever your AWS account ID is, you just take this one and you put it in here, and you keep the location global. Just take this one, copy, and paste it in here. And if everything is good, it will tell you that it created the workload identity pool provider ID my AWS provider. So that's step 2. Let's look at the step 3. Step 3 is we impersonate a service account. So what we do here is we say gcloud IAM service accounts, add IAM policy binding service account email, right? So what we need to do now here is we need to create a service account and give that service account permission to access GCS bucket, and then we come here and we update the values. So let's go and do that. So we are in IAM, we click on service accounts, and we say create a service account, and the service account name we want to give is SA minus read GCS bucket, and we click on create. In the role we say storage not the admin, or we just give it admin, storage admin. You don't want to do that. You only want to give this account permission to read the storage, not to be the admin, but just to, for the demo, this is okay. Click on continue and you click on done. Now we have our service account. This is the service account that will be assumed or impersonated by our AWS Lambda function. So we copy the email of the service account, and we paste it here, and we say role is IAM.workload identity user, and the member is iam.googleapis.com/project/project number. So we need to update this project number. So what is our project number? So if we go to home, we should get the project number from here. Locations/global/workload identity pools, and here we update pool ID. So our pool ID is ID minus my AWS pool. So let's just copy that. /attributes dot AWS underscore role /AWS role name, right? So we need to update AWS account ID. Our AWS account ID is this one. and our AWS role name is that's our role name. Okay, so we are ready to take this particular command and we can take this one and we can run it. Once again, we updated the email address of the particular service account, and we updated rest of the values with AWS account, AWS details. So we take this, we copy this, and we come here. So yes, we come here, in here, and we paste it. What it's gonna do is it's gonna update the IAM policy for the service account, and it's gonna say this service account can be assumed by this role called role minus read from GCS if it is from this particular account. So this is the ARN of AWS. If you work with AWS, you understand what the ARN is. So that's the AWS ARN, and that's pretty much what we had to do to set this up. Now what we do is we download this particular file which we need to attach with our code. So this particular file is gonna be, we have to update the variables here. So we say gcloud IAM workload identity pools create credentials config projects / project number. So my project number is this one, global, and my pool ID is this, and my provider ID is this. And my service account email address is this. And the output file path, so we will just name the output file as GCP cred for AWS, and minus AWS is good enough. And we take this, copy this, and we paste it in here, we run it. And now if we list the content, you'll see there is this file called GCP cred for AWS. There is the one that we just created. So if you look at this, what the content of that file is, there is nothing in here that can compromise your account, but you still don't want to lose this file. But in case if you lose it, you will be still okay, because it does not contain anything that can compromise your account. All you do is you just go back there and invalidate this file, and you just generate a new one, so you will be good to go. Basically it just uses this, your AWS Lambda function will actually use this file to generate the temporary credentials. There are no credentials in this file. So now what we do is we download this file. So we just say Cloud Shell download this file, and we say download. So now that the file is downloaded, what we do is we copy this file in a particular directory in our Lambda function, and we go from there. So I'm just gonna go and do that. Okay, so what I did is the file that we downloaded, I took that file and I created a folder in here called auth from AWS, and I just pasted that file in here. That is all I have done, nothing else. Now what we need to do is we need to take this file and we need to put this file in our Lambda function, make it available to the Lambda function. So we come here and we edit our script, our shell script, where earlier we were only adding app.py, but now we need to add this auth from AWS, another file, this folder. So everything in this folder we add, and we add our app.py. That is all we are doing, nothing more than that, right? So we just come back here and we say create the deployment package again. Okay, so our deployment package is created. Now we still have everything that we had earlier. We have the package folder, we have the app.py. On top of it, we have this auth from AWS folder inside this zip file, and it has this particular file in it. So this will help our Lambda function to grab to get this STS token from GCP, and which call will actually do that. So if you look at app.py, where it says create the storage client, and it says get the bucket, this is where it will go and say, oh, before I can create this client, let me figure out how do I get this temporary token, so I can work with that. So this is GCP's SDK takes care of doing that for us. Our code does not change, it will run as is. We haven't made any change in the code. So now that we have the zip file ready, what we will do is we will go to the AWS, come here, and we will upload the new file. So we go to code and we say upload from zip file, upload, and we just created this file here, and we say save. Okay, now we are almost there. Now one last thing we need to do is we need to tell somehow GCP SDK has to know where this credential file is. It can be anywhere, right? So we put it in here, but you can put it anywhere. So that is why there are two things you need to do. Is you need to set this environment variables, right? So our GCP cred for AWS, so that is what our file name is, right? So we will set these two environment variables in our Lambda function. So we come here and we click on configuration, environment variables, edit, add the environment variable. That's the key, Google application credentials, and the value is /auth from AWS / GCP cred for AWS. So from the root, go to auth from AWS and grab this GCP cred for AWS file. So that is one. And the next one we need to add is the cloud project number or ID. So Google Cloud Project, Cloud Project ID. This is wrong. So my Cloud Project ID is this. And we click on save. Now we are done. So now if we run this, hopefully we should be able to get the files, list the files from the GCS bucket. So this is the previous execution which was timing out. You can see it here. But if we run it now, and let's see what happens. Okay, so I will click on test, if I can find that button, and see what happens. So I will click on test, and you can see that we are successful. We retrieved the files from GCS bucket without generating the key for the service account that has access to this particular GCS bucket. Ooh, this was done, but okay, it worked, so all good. So this is one way of doing it for AWS, right? You want to do it for Azure, there is a different way of doing it. The process more or less remains the same. It's just different values for your variables, right? So your instead of your account ID, you will have subscription ID or tenant ID or something like that for Azure, and so on and so forth, right? So that is how it works, and that is how the whole thing is set up. So I hope you enjoyed this little demo, and hopefully you will give it a try, and let me know if you have any problems, or let me know how it works or how it goes. Thank you very much.